Hello again. We're going to talk about matter and motion. Physics, if one has to give a general definition of it, is the study of matter and motion. And the laws governing matter and motion were formulated by Isaac Newton a couple of hundred years ago. And he developed three laws of motion which essentially cover most of what's called Newtonian mechanics. And we're going to just briefly go over what those laws of motion are and speak a little bit about some of their implications. Okay, well, there are three laws of motion. They're called Newton's three laws. And let's just start off with the first law of motion. There's some rather wordy definitions of each of these, but we're going to summarize them in some simple phrases. The first law of motion is the so-called law of inertia, and the formal definition of it is that if you have a body at rest, say a ball bearing or something, and it's just sitting there, then this means that there are no forces acting on it. The curious thing about Newton's first law is that a body sitting at motion is a special case of a more general phenomenon, and that is that if you have a body moving at constant velocity, that body will tend to continue moving at constant velocity. Now, we need to define more precisely what velocity is. You can see that I've drawn it as an arrow. This is a notation that describes what's called a vector. And velocity is not the same as speed. It's sometimes confused with it, but velocity is essentially equal to the combination of speed and direction. And in the case of these vectors, speed is given by the length of the arrow, and of course direction is given by the direction of the arrow. Now, if you have a body traveling at constant velocity, it will tend to continue traveling at constant velocity, and a body at rest will continue at rest. And this tendency of bodies to either continue moving at constant velocity or to continue at rest if they are at rest indicates a property of matter that's known as inertia. Now, the first law of motion, Newton's first law of motion, is actually a special case of a more general law, the second law. And this law is known as conservation of momentum. And the second law, Newton's second law, simply states that a property called momentum is conserved in any kind of object that happens to be moving. Now, we have to define what momentum is. Momentum has a very simple definition. Momentum is equal to the mass of an object times its velocity. Newton called this quantity of motion, and it's simply the product of mass times velocity. If we use our notations for units, mass has units of kilograms, velocity in the SI units has units of meters per second, and so the units of momentum are kilograms meters per second. Now, whenever you have an object with momentum, it will tend to keep that momentum. As I said, this is a more general statement of Newton's first law of motion. However, if you have a force acting on an object, this is going to change the momentum of the object. If you have, for example, an object traveling at constant velocity, and you come along and exert a different force on it, then what that's going to do is it's going to tend to cause that object to accelerate. And it will continue accelerating as long as you are exerting a force on it. And so this leads to a definition of force. This is the real